Hi, everyone. This is Andrew Cutler with a brief message about changes at the NEI podcast. Our host, Sabrina Siegel, is moving on to an exciting position in the field of TMS research, and we couldn't be happier for her. So what does that mean for NEI podcast? Well, we'll be taking a temporary hiatus over the summer. From July through September, we will revisit some of our most compelling episodes on topics that remain as relevant today as when they first aired. New episodes will resume in the fall, so make sure you're subscribed so that you don't miss out. This summer, NEI Podcast is revisiting some of our most compelling episodes. In today's re-release, Dr. Sabrina Siegel interviews Dr. Nina Kraus, a neuroscientist who studies the biology of auditory learning and how our brains are shaped by the sounds of our lives.
In this episode of the NEI Podcast, we are discussing the clinical application of auditory neuroscience with Dr. Nina Kraus. Dr. Kraus, welcome to our show.
Thank you for having me.
My first question for you is, what led you to pursue a career in auditory neuroscience, and what is the mission behind your laboratory, Brainvolts? I love that name, by the way.
Well, on one hand, I may have just stumbled upon what I do because it just happened. But if there is a reason that I need to come up with, it would be that, I grew up in a house where more than one language was spoken. Mm-hmm. My mom was a musician. The sound was very important for what I cherished, which was all of those interactions. And I did end up going to, when I went to college, I majored in comparative literature.
Right.
Because I spoke some languages and I like to read. And then I took it was a distribution requirement, a biology distribution requirement. And I just fell in love with biology and, thought, wow, if I can manage to connect some of my interests. It was about that time I found a book by Lenberg called The Biological Bases of Language. And I thought, ooh, now that's interesting. And so, I kind of started there. And, if you look at the home page of our website, Brainvolts, which I encourage everybody to do, please. Yes. It is a labor of love.
They've included that in the show notes for everyone.
You will see that there are pictures, icons for the different kinds of things we do. Mm-hmm. So we study music, we study concussion, we study hearing and noise, various language reading disorders, what happens as we age, bilingualism, all these different things. And you might wonder, what are they doing at Brainvolts? But it all fits under the umbrella of sound and the brain. And I really wanted to put this information and the perspective, just this view of how sound is pervasive. It's a pervasive part of our life. It is such a big part of so many different things that we do, all those topics that I mentioned. And I wanted to put it all in one place in this book.
That is so exciting that was going to be my next question is, what led you to writing the book of Sound Mind? I love how sort of transparent you are about the mission in the book. And it's very unique and very interesting.
Well, it was not like anything I'd done before. I've published many scientific articles, but I realized that as I talk to people, somebody I might sit next to on a plane or somebody at dinner, whether I know them well or not, whenever it gets around to what I do and sound, people are interested. Mm-hmm. And yeah, they should be. It's one of the most interesting topics ever. And so I thought, boy, I would love for everyone, no matter how much or how little you might know about the topic, I'd like to write something that everyone can get something out of, and to put across how important sound is in our lives, because people don't really realize it. Sound is invisible, like other powerful forces in our life, like gravity. And, we live in a very visually biased world.
Right.
And the most common comment that I have been getting from people who have been kindly corresponding with me after reading the book is, I had no idea. I had no idea. Sound is right there in my life. And I just didn't recognize how potent a force this is.
Right.
And so I wanted to talk about it. And being a biologist, my perspective is as a biologist. So it's a biological perspective of sound and how it makes us who we are and how it shapes the world that we live in. I wanted to write in an informational but conversational tone.
Right. And that definitely comes across in the book.
So it's conversational. But you might notice that 20% of the book is references.
Yeah.
So I'm not just saying.
Yeah. And on that note, I mean, what I love so much about the book, and we're talking about the book Of Sound Mind, is that you share so much of the research and the science that it's based on, but you do it in such interesting and fascinating ways. It's, you're telling a story and sharing the results with us. With respect to that, you mentioned something in the book several times that is studied and tested in the Brainvolts lab called the frequency following response, or FFR. Why is this important in auditory research for clinical applications?
Well, the FFR, or frequency following response, is an interesting way of getting biological information from the brain, how the brain responds to sound. I want to first back up just a minute and just mention something that I also was trying to get across in the book that has to do with the conversational tone, is the fact that science is a deeply human endeavor. Science is performed by humans. And so, of course, I'm going to tell you stories about, all the people at Brainvolts and, how all of this fits in to the lives of people. So that's an important part. And, then leading to your next question about, what about the frequency following response, the FFR? What is it? It is, as I'm talking to you now, of course, the neurons in your brain that respond to sound are producing electricity. And we can measure your brain's response to sound in humans using just scalp electrodes. And we have figured out, that the frequency following response itself has been around for decades. But we capitalized on this idea and made it much more precise to the point that we can really measure the details, the biological details of sound processing as you are listening to any particular sound. So,
amazing.
yeah. And, you can, I've done, certainly started, and we work recording from individual neurons. And, we still have an animal model that informs our work. But really, the most interesting thing to me is to be able to understand human auditory processing.
Right.
And, I really wanted to develop, and our group really has developed a way of, with tremendous accuracy, measuring the brain's response to sound to the point that, the responses that we obtain, they resemble, they look like, and they sound like the sounds that the person is listening to. And it is detailed and precise enough that I can see the difference between your brain and my brain. We can look at each individual person. Each one of us hears the world in our own way, and largely based on our life in sound. And we can see this, we can see it biologically very clearly. I can measure, we can take piece of music or some speech or whatever we want to examine and, have you listen to it, measure the brain's response as you're listening to it. And then you can have me listen to the same sounds. And, we all have our own neural signature.
Right. I think that's incredibly powerful when it comes to applying this knowledge in the clinical sense. We'll get to it a little bit later in the interview, but I was so amazed with how powerful this component of sound can be in the clinical setting. And just through all of the research that you're doing at Brainvolts, it's really, really inspiring. And I think it gets at that focus of sort of when we talk about things like individualized medicine, when you look at individualized responses like neural patterns, and within the context of sound, that may be able to open up whole doors. And, you go into that toward the end of your book. And I think it's so exciting. So looking at the neurobiology a little bit more, can you share with us how exactly the afferent and the efferent systems in auditory processing integrate to shape the way that we learn and the way that soundness of mind is formed?
Well, there are pathways that connect our ear to our brain.
Mm-hmm.
And the ear-to-brain pathway is known as the afferent pathway, afferent.
Mm-hmm.
And there are many more pathways that connect different parts of our brain to each other, from the cortex, the limbic areas, any part of the brain, all the way through the auditory system down back to our ear.
Mm-hmm.
So the efferent system is our brain-to-ear pathway. And before I get too much into the ear-to-brain and brain-to-ear pathways, let me say that the hearing brain is vast.
Mm-hmm.
The hearing brain engages how we think, how we feel, how we move, and how we coordinate information with our other senses. So, the fancier, more formal way of saying that is that the hearing brain engages our cognitive. So that's how we think, what we pay attention to, what we remember, what we know. Cognitive,
Mm-hmm.
sensory, so all of our senses. Motor, how we move. And reward, how we feel. So the hearing brain engages our cognitive, sensory, motor, and reward systems such that, there is a tremendous interplay among all of these systems in the brain in response to sound, engages all of these things. So you can imagine that there is afferent and a lot of efferent. The efferent system is more massive than the pathways going upstairs from
Mm-hmm.
ear to brain. And with increased evolution, there is more and more development of the efferent system, because it's the efferent system that's the secret sauce. That is what is responsible for our ability to learn.
Right.
And as we learn things again and again, eventually the things that we have learned very well become our default or our afferent response. So, as soon as you stimulate the ear, it directly goes to the brain very clearly. For example, the sound of your name. It's something that even if you're sound asleep, if someone says your name, you're likely to respond to it. And the book is the long version of, how it is that we learn and what are the different pathways and networks involved. A very short summary of this learning and efferent and afferent piece is I wrote a 400-word, so that's maybe a page and a half, maybe a page. I wrote a 400-word article for hearing research. So the journal is Hearing Research, and it is called the Beams Hypothesis.
Wow.
And, you can put up a link to that, but the B stands for brain.
Okay.
The E stands for efferent.
Okay.
And so with learning, we stimulate the efferent pathway. The afferent pathway is what happens after we have learned that information that finally creates our memory. So that's the M, our memory for sound, S.
Hmm.
So it is really this Beam's hypothesis, this interaction of the afferent systems that together, of course, engaging our cognitive, sensory, motor, and reward networks. All of this is all part of that system.
Mm-hmm.
That is how our sonic memories are formed. That's what makes us to the extent that, if you hear the sound of someone's voice who why do we say, oh, it's so good to hear the sound of your voice?
Mm-hmm.
Because you have really learned through your emotions and your movements and your combinations of everything that you've learned about this person and what that sound means.
That's so interesting. Thank you for sharing all of that. And I'll definitely post a link to that in the show notes. So speaking of, noise processing, how would you define noise, and how is noise exposure damaging? How does safe noise affect us over time, and how might it damage the developing and non-developing brain? And
So noise is, you can define noise any number of ways. Here, it's taken in the sense of unwanted sound or unnecessary sound that can get in the way of our health. So everybody knows that very loud sounds can damage your hearing.
right.
We all know that.
Mhm.
But what is less known is that moderate level sounds, safe sounds, really have an effect on our biology. So it won't damage our ears, but it is bad for our brain. And many of these are sounds that we often aren't even aware of. So, I don't know if you've experienced, when the truck outside your window that's been sitting out there idling, when it cuts the ignition and suddenly it's quiet, or you're in your kitchen and the refrigerator turns off, or the heating or air conditioning turns off, you find yourself breathing a sigh of relief. And you didn't even realize that sound was there, but clearly it was there, because when it turned off, you were relieved.
Yeah. It's so interesting.
So these moderate level sounds, these safe sounds, because, they don't exceed the level that will cause damage to your ear, but they will, first of all, because sound is such an evolutionarily important sense, in a way, we're in a constant state of alarm.
Yeah. And it's interesting that you address that point in the book, because I didn't even realize that's what happens. But I think that's so often the case, where there's these, sort of background noises we get used to, and it's not alarming, so we're not paying attention. But when something shuts off, we notice that, and it's like when you draw your attention to all of those things, you start to open up your eyes and realize how powerful that noise can be, just overall, and how it can influence, your state of being and cognition and your overall health. So it's fascinating.
Yeah. It clearly takes a biological toll.
So interesting. We're going to turn a little bit to some of these clinical applications from Brainvolts and related research as well. Why is audiological evaluation important in the assessment of autism spectrum disorder, or ASD? What has research shown about how autism affects the way that the brain processes the subtleties of spoken language, even in children with ASD and normal hearing?
Yeah. So, typical and classical audiology will measure hearing thresholds. Like, is there a hearing loss? Can a child hear all of the sounds? The raise your hand when you hear the beep kind of evaluation. Most kids on the autism spectrum are perfectly normal with respect to their hearing thresholds. But with respect to how the brain make sense of sound through the frequency following response, through the FFR, we can see, for example, our brain will track a change in pitch. For example, if I'm asking a question and my voice goes up, or if I'm making a statement and my voice goes down. So we measure the brain's response to these very simple pitch trajectories, which of course gives you a lot of information about not what you said, but how you mean it. Right?
Right. Yeah. Exactly.
And what we discovered is that kids who are not on the autism spectrum will process those simple pitch trajectories very well. They will very clearly follow the pitch changes. And some of the kids, again, we're all different, and autism is, it's why it's called as a spectrum. But some of the kids on the autism spectrum fail to automatically process these changes in pitch.
Right.
And so, that can really lead to misunderstanding. Are you saying something because you're mad or sad or angry or asking a question, making a statement? These are all, cues that are in sound.
And I think it's important to address the fact that they're cues about our social interactions. Would that be safe to say?
Absolutely.
Right. And so I could see how that's could potentially have such a powerful effect, and if you're not able to pick up on those cues, that could be really challenging, right?
Absolutely. Absolutely.
Wow. That's so interesting. What has your research shown about hearing loss and dementia? We've known in the field, we've known a little bit about the connection between this for a little while now. What does the increase in auditory noise mean for just aging in general? What are sort of the system-wide alterations that occur with hearing when we age? And what is known, can you speak a little bit more about this connection between the rate of cognitive decline in patients with dementia and hearing loss? And you state in the book, I believe, that hearing loss is considered to be the most modifiable dimension of dementia, which I think is so powerful when you think about it, right?
Yeah. And, it all goes back to the basic premise and principles of the fact that hearing engages our cognitive, sensory, motor, and reward networks. So often as we get older, we lose some of our ability. We have some ear damage. It's called presbycusis. And, the kind of tests that we were just talking about that the kids on the autism spectrum, nail, they do perfectly well on. As we get older, we often start losing some of the hearing especially for the higher pitched, the higher frequency sounds. And so it makes the perception of consonants, D, B, G, difficult. Those are the parts of speech that are especially vulnerable to background noise. So, if you're in a noisy place, you're going to have difficulty with that. And as you lose your hearing, you lose that connection with what you know.
Right.
Because, you aren't having you might just be listening to the susurration of sounds of people's voices, but you're not picking up on what they're really saying. So you're not thinking about what they're saying. You're not engaging your thoughts. And, by not engaging your thoughts and by not engaging with other people, your emotions, you just lose out. And I think that part of the panic that I think many people feel, and I think there's been a lot of media attention drawn to, signs of Alzheimer's and dementia and difficulty thinking. I would expect that a lot of that is just coming from an inability to hear properly. And, people who eventually get hearing aids and learn to use them. By the way, it takes a while for your brain to learn to use a hearing aid. After they have learned to use the hearing aid, they will say, "Oh, I think so much better." And I mean, an example that I relate to is, so I wear contact lenses. And if I'm going to get on a phone call, or, if I'm going to talk to you, I want to put my lenses in.
Right.
Because when I have my lenses in, I'm just looking around my room and I'm just so much more tuned in and oriented to the world.
Right.
And, even we're having a complete audio conversation. So you're wondering, why would my vision even matter? But it sure helps me think better when I can see clearly.
Yeah, absolutely. I completely understand that. Now, when using the FFR, what has the research in your lab with respect to the brain's response to sound found when it comes to aging? Can you explain what FM sweeps are in your research and why this is valuable in auditory research, particularly the focus on aging?
Yeah.
And what were some of those findings?
Yes. Well, so sound, first of all, consists of ingredients like FM sweep. Again, because sound is invisible, it's harder to visualize these ingredients. But, for any visual object, you have the shape, the size, the texture, the color. These are ingredients. Sound also has ingredients like pitch and loudness, timbre, and, the harmonics, FM sweeps, AM sweeps. So these are parts of the ingredients, the acoustics of sound. The FM sweeps are very rapid changes in frequency over time. And it is the FM sweeps that help us distinguish a B from a G. Did I say bag or gag?
Right.
And if you start losing the ability to hear those FM sweeps, this is something that happens as we age, is the brain's ability to process some of these ingredients decreases. Another ingredient in sound is timing. There are so many timing cues, and hearing is our fastest sense.
Right.
So as we age, there are a number of, again, if you just look at a population of people who are older, you will find that the brain's processing of FM sweeps, of certain timing cues, you kind of slow down. And there's also some neural noise, which is, just think of it as background static in the brain. And so this happens typically, but again, not in everyone by any means. And one of the very best things that you can do is to have a sound mind. So, my definition of a sound mind, and the title of my book, Of Sound Mind, is what hearing is, which is this combination of our cognitive, sensory, motor, and reward networks. And these are modified based on our past, our present, and will be modified in the future. So this is a very, dynamic system. So the choices that we have made, or that we will make for our lives in sound, are very important. So, for example, if you are an older musician, someone who has, and I'm not talking about a professional musician necessarily, anyone who has regularly made music throughout their lives, many of these changes in the processing of sound, the FM sweeps that are so important, the timing, those aren't there. Right. So, if you measure the brain's response of a younger person and an older person who has regularly developed their sound mind throughout their lives, say by making music or speaking other languages, you will see that the brain's response to sound is indistinguishable between an older sound mind and a younger person.
And that's fascinating. I just think that's incredible. To add to that, I'd like to ask you, can older individuals observe improvements in hearing if they begin musical training you're talking about, musicians from sort of an earlier age, and then how those compare to non-musicians. But what is the overall effect of musical training when it comes to perhaps preventing hearing loss? What is known about that? Because I found that so interesting in your book.
Yeah. Well, the sound mind continues to learn throughout our lives. And you can start learning anything, music, for example, at a late age, and it definitely will strengthen your sound mind.
Mm-hmm. Mm-hmm.
And these are biological changes that we can see over time.
Yeah. Wow. So it's never too late. That's very inspiring. And I think something else that you shared in your book I found so fascinating was that the research that was conducted showed that training for even just a little bit in early life, having some musical training, like perhaps learning an instrument, later in life paid off in terms of auditory processing. Can you tell us a little bit about that? Those effects are so profound that even later in life, they showed to have some healthy effects on the brain.
Yeah. So a little goes a long way.
Mm-hmm.
And if you have, like I often will ask an audience, how many of you have played a musical instrument sometime in your life? And a lot of people will raise their hands. And then, I'll ask, well, how many are still playing now? And it's not as many.
Mm-hmm.
But all those people who had played music at an earlier time in their lives continue to reap the benefits of that early experience.
That's
because, when you make sound to meaning connections, and music really is the jackpot in terms of engaging our cognitive, sensory, motor, and reward systems. So when you start learning these sound to meaning connections, which must happen as you engage with a musical instrument, and yes, of course, voice counts. When you are making music, you are engaging, you are strengthening your sound mind, you are making sound to meaning connections that once you make them, you continue to make them and reinforce them throughout your life. And we can see in older people, so if you take two 75-year-old people, and, one has had has made music early in life, 40 years ago, and another has just never made music, you really can see that the response to sound, all those important, meaningful parts of information in sound, those FM sweeps, the timing cues, all of that information is just so much stronger in a person who has had early musical training.
That's incredible. And now, can someone who's experiencing difficulty with auditory processing later in life, can that be corrected through training? I was thrilled at some of the results you shared in the book from Brainvolts about this auditory training study that was conducted on sound processing and aging. Can you share a little bit about the findings from that study with us?
Sure. And, in all of these studies, if anyone is interested in the details as you read the book, you can, then go to our Brainvolts website and download the original article. But this was work that Samira Anderson, one of the doctoral students in my lab, she led a study of older adults, and she had them take part of a computer-based brain training program. This was put out by Posit Science, and it is especially auditory-based. So, people were taught to listen to the details and sound, and they got feedback as to what they were able to hear and what they could remember. Again, cognitive, sensory, motor, and reward, like you would feel good if you got more points. And then the control group was also older adults, completely matched in their audiogram, who watched educational videos. And they had to answer questions about the videos for the same amount of time. This was a 6-week 6-8 week program.
Mm-hmm. Mm-hmm.
And over time, what we saw is that only the people who had learned to make these sound to meaning connections, who had strengthened their sound mind, their responses to pitch, timing, timbre, these important ingredients in sound became strengthened.
Wow.
And on top of it, they were able to hear sentences and noise better. They were able to remember better. And, this is because of this enormous connection between hearing and who we are biologically.
Mm-hmm. Mm-hmm.
But it matters, it matters how we spend our time.
Right.
Early on, it matters.
Mm-hmm.
I like to think that healthy aging begins in childhood. But now, no matter how old or young we are, there are choices that we can make in our lives for how we spend our time in sound. Noise, the impact of noise. How do we stimulate our sound mind in for good and, for better and not for worse? And the last chapter in my book is very much, as you'll remember, it's my call to action.
Yeah.
That we really can make choices for our educational systems, for
Absolutely.
medicine.
Yep.
We can personally make choices for ourselves, for our children. And it's up to us. It's just up to us.
Yeah, I found the book very empowering, especially at the end. That was such a great finale to the book. Related to what we're talking about, what is the effect of bilingualism on Alzheimer's disease?
Well, this is work that Ellen Bialystok has done.
Mm-hmm.
And what she has found is that older people who speak another language are less likely, that basically the speaking of another language can help stave off cognitive decline.
Yeah, that's incredible. I think it states in the book sometimes up to 4 to 5 years potentially, which is pretty amazing. Yeah, I think it goes back to that connection of what we're talking about, where, it's so much more than just sound processing. It's how it's being integrated with the other neural processes. And I think it's really great to just spread awareness about this and open more conversations about these things.
Well, one of the things that happens when you speak another language, and it's interesting because there is what we might call the musician signature, and then there is the bilingual signature, there's the autism signature. So, if you just take groups of people who, have made music or speak another language, well, so both the bilinguals and the musicians will enhance certain sound ingredients. So certain sound ingredients will be strengthened. So you might say, well, their sound mind is strengthened, but it's strengthened in a different way, because some of the ingredients, if you speak another language, the fundamental frequency, or it's something that is very important in, like as I'm talking now, I have a certain voice pitch that binds, you can tell that it's me talking, that binds my voice and pulls it away from, makes it distinct from other sounds that you might be listening to. And people who speak another language have especially good responses to the fundamental frequency, which is a very important cue for pitch that can help you identify, for example, a person in a noisy place. Whereas the musician signature is more the harmonics, the FM sweeps, the timing that are enhanced. And, it's really rather fascinating. And these are ingredients that we need for learning language. We need for reading. We need, again, back to, your and our interest in clinical applications. It is educationally so important for our children to make music.
Right.
To learn another language. This will help them to think.
Absolutely. What does it mean to have a quieter brain when it comes to neural noise? How do athletes' sound minds differ from people who aren't bilingual or musicians? So you were talking about the bilingual signature, the musician signature. Would you say that there's also sort of an athlete signature as well?
Yes. So we are doing some really fun and interesting work at Northwestern University. We have an NIH grant that supports a 5-year study of all of our Division I athletes. So these are our Big Ten athletes, all 500 of them, males and females, playing every sport that Northwestern competes in.
That's incredible.
And we follow them for 5 years, and we are especially interested in looking at concussion. So kids who get a concussion, we've discovered, and this has now been replicated in other places, that making sense of sound is one of the hardest jobs we ask our brain to do. So if you're going to get hit in the head, it's going to disrupt this wonderful, magical, precise processing that our brain does with sound. So if an athlete sustains a concussion, we will measure their response shortly after they have received the concussion, and then we follow them very carefully. And in fact, a certain percentage of people who receive a concussion, in fact, you can see that concussion disrupts the hearing brain. And this has implications for hearing and noise, for, being hypersensitive to sound, all kinds of hearing problems that haven't really been paid attention to much until now.
Right.
But at the same time that we are doing this study and we're interested in concussion, we're measuring every athlete's FFR, their response to sound at the beginning and at the end of every season. And so we have these incredibly elite, fit people. And we were wondering, would it, if we compared these Big Ten athletes, 500 of them, to another 500 Northwestern students. So demographically, they're very similar, but, one group is our elite athletes. And we wondered, might the pitch and timing and timbre, might some of these sound ingredients be enhanced in the athletes? And we looked at that, and, initially, we saw no. In fact, the pitch, timing, timbre, all of these ingredients are processed in the same way in the athlete than in the non-athlete. But we discovered that the athlete has a quieter brain, is that, your brain is always on, and your brain, the currency of the nervous system is electricity. And so there's always this static, this unsynchronized. Just think of the static in your radio. So there's this electrical activity. And we found that the athletes have much less of it. They have quieter brains, which translates to, in fact, having them make better sense of the environmental stimuli around them, like sound. So in fact, their pitch and timing and timbre and all of these ingredients are processed better. And, we can think about, so the musician and the bilingual have enhanced sound processing because certain sound ingredients are enhanced. The athlete has enhanced sound processing because the background noise is less in the brain. They have quieter brains. So, the end result is that these different groups of people have enhanced sound processing, but they do so, all three of them, they do so in different ways.
That's so fascinating. How can sound be used for the assessment of traumatic brain injury and other neurological conditions?
Really well, in that, when you measure the FFR, the frequency following response, the athlete, say, doesn't have to perform any kind of behavioral measure. So, he doesn't have to answer questions, or he can just sleep. And we can measure the brain's response to sound, which is this very beautiful, and clear measure of brain health.
Yeah.
So, the athlete can and by the way, they all love to have their FFRs measured because these athletes work so hard. Oh my goodness. And so, to have a couple of minutes in the day where they get to sit in a comfy chair and we just measure their brain's response to sound. But so, you can do this after a concussion and you can see whether there is a disruption in the processing of sound.
Yeah. Yeah. Wow. It's so exciting to see the potential of where that research is going to go and, what we might be able to do with it in terms of concussion. And again, it's interesting to think that might have been right in front of us all this time, but people weren't paying attention to it necessarily, So it is interesting to see once again how powerful that role of sound can be clinically. In your research, how do the timing and the size of the fundamental frequency identify children who have suffered a concussion versus those who have not? I found this really interesting.
Yeah. So it is this fundamental frequency, which is a very important pitch cue, and it really helps us figure out, that's the sound of the cleats on the dirt. That's the sound of Joey calling my name. So it helps you cohere or bind auditory objects, like the sound of my voice can be an auditory object. And so we find that following concussion, the size of the strength of the fundamental frequency becomes diminished. And the more severe the concussion, some of these other ingredients also are diminished. But, we can then follow the athlete and sometimes it's over just a period of a week or so or two that the response normalizes. And, what a really nice way, it's a, biological way, one more piece to add to a trainer's decision as to whether the athlete is ready to return to the field, to return to play or return to the classroom, return to learn. We know that the chances of getting a second concussion are much greater once you've had one concussion. And, it's been speculated that one of the reasons is because the athletes return to play before their brain has healed.
Right.
And so, we're hoping that this will become part of a standard of care and it will become one more metric, one more index that the people making these decisions can have to make the safest decisions. And that's, one of the reasons I love working with the athletes and the trainers and everyone at Northwestern is that, the trainers are so interested in athlete safety.
Absolutely. Yeah. Yeah. And I love that you address, even in your book, that there's no one test for assessing concussion, but that this could add a really powerful component to being able to assess not only concussion, but it sounds like even the recovery from a concussion, which is incredible because, we've been looking for something like that for a long time, it seems. How did you use sound processing to evaluate the stage of head injury and recovery in college athletes? Can you share a little bit about what the findings were with respect to the FFR? And do you think that the FFR could potentially be a screening method for chronic traumatic encephalopathy in the living, which would be amazing?
Yes. Yeah. So yes, I certainly do think that having a biological measure that can be performed on living beings, this is a really good candidate for that. And we've really been able to follow athletes over time. Many of them recover completely with respect to their brain's response to sound. We have seen some who, based on their history of concussions and more concussions they've had, some aspects of sound processing, especially the fundamental frequency, that keeps lingering.
Okay.
And so that, that may be a legacy of repeated head injury.
Right.
So I really do believe that the FFR can become a standard of care, a way of assessing injury. And also over time, if an athlete has sustained multiple concussions, This is really a way of being able to get a sense of, is this imprecise processing of sound, is it lingering or not?
Yeah, and I think that would be so amazing, because it's been very challenging in the field to assess just how much there has been an accumulation of, say, mild traumatic brain injuries. So to be able to utilize sound to detect that, I think, is really very powerful.
I believe so.
So with that, what are your final thoughts about how we can each preserve and protect our sound minds?
Well, I think a very important part of what sound does for us is sound connects us.
Mm-hmm.
You and I right now, we're having this conversation. We don't have a script. It's very live. It's very alive. It is a way of connecting. And it is a very special way of connecting because it is a back and forth.
Right.
It is a reverberative process. Ian McGilchrist calls this betweenness. But the back and forth, the reciprocity, the reverberation that can happen between human beings when they communicate through sound is unlike anything else.
Right.
If you, and sound is unlike anything else. I mean, once sound has occurred, it's gone. So, inherently it's very much alive and very different from, if I'm going to write you a text. I can curate the text. I can, just make it exactly how I want it to be before I send it. And then you can have it. It's very different from the kind of betweenness that you and I are experiencing right now. So I'm afraid that, we are we're forgetting about sound. We're forgetting how to listen. We live in a world that is full of unnecessary sounds. And I think one of the things that we can ask ourselves in the sounds of our own lives is that noise, is it necessary? Do I need to wake up my neighbor when I come home late at night and I lock my car? I mean, there are just so many things like that. If you just think about it for a minute, you can do something about those things. It's right there in the manual.
Right.
And I think we need to talk to each other. We need to talk to our children. We so often put a child, give them a tablet at the dinner table so that then they're not part of this give and take, this conversation, and that they're, not part of just learning how to listen, how to take a turn.
Right.
This is so important for language development. I look out my window sometimes and I see people with their kids and they're on their phone, and I want to open the window and say, talk to your kid. Don't talk to your phone.
Exactly.
But these are, and I love my phone. So, these are choices that we can, and never, ever is anything, hard and fast and black. And my students are always frustrated because they always want to know the answer. And my answer to them is usually, it depends. So, the context really matters.
Exactly. Yeah. And I think we get so used to sort of background noise, and we're bombarded all the time with noise, as you've mentioned, that sometimes we forget to listen, and I think with the importance of communication, as you're sharing, there also comes the responsibility to listen, right, as well, to each other, and really take that sound in, that noise,
And to connect again, sound connects us. That's a big message of my book.
Right. And it's beautiful.
Sound connects us. And if you think of, have you ever sung harmony with somebody?
Yes, I have.
Right? So it's this back and forth. You're listening to yourself, you're listening to them, they're listening to you, they're adjusting, they're movements, motor movements to, it's just this beautiful example of betweenness. And, every language, every culture has music, and what a wonderful way to connect.
Well, thank you so much for sharing such an incredible topic with us today, and thank you for being on our show.
Thank you so much for having me on your show.
Thank you so much for joining us for another episode of the NEI Podcast. Please let us know what you'd like to hear more about by leaving a review. Don't miss another episode. Subscribe today.